example 1e, we are going to compute the exact value of the secant of negative pi. So the angle we're interested in is negative pi. We have a negative angle. That means we are doing a clockwise rotation. Okay. When you go to the unit circle and you scan this thing, you do not see an angle of negative pi. You see an angle of positive pi, but not one of negative pi. Okay. So in order to figure out the secant value, okay, we're going to have to figure out what angle on the unit circle is coterminal with negative pi. Okay, and we will use that angle and its coordinates on the unit circle to compute this secant value. Okay, all right, so just like we did in part D, we can kind of do a little calculation to figure this out if you don't already know it. We're just doing radians instead of degrees here. So the full circle is 2 pi radians. Okay, we're going to go ahead and subtract out pi. We're doing the minus pi because that's the angle here. Okay, and if you have 2 pi's and you take away 1 pi, you're going to be left with positive pi. Okay, so what we're going to see is that negative pi, that angle, and positive pi, these guys are coterminal. Okay, remember pi radians is 180 degrees. Okay, so if you go back to the unit circle, okay, we've got our initial side already drawn in. Okay, if we're going to try to draw negative pi, our angle that we're interested in standard position, okay, we need to put in the terminal side. Okay, so we would start along our initial side and we're going to rotate clockwise by pi radians, which is 180 degrees or half a circle. Okay, so this is going to be our terminal side. This is going to be what it looks like. Okay, the direction and amount of rotation is going to look like this. We started along the initial side, we rotated half a circle clockwise. Okay, this is going to be negative pi, okay, or negative 180 degrees, negative pi radians or negative 180 degrees. Okay, that's what this angle looks like. Okay, this angle is coterminal with positive pi radians or positive 180 degrees. Okay, if I started along the positive x-axis and I rotated counterclockwise half a circle, okay, I would get to the same terminal side. Okay, so this red angle is going to be pi radians or 180 degrees. Okay, so just like I said when I wrote this down, the angles negative pi and positive pi are coterminal. Okay, they have the same beginning or the same initial side and the same terminal side. So what this tells us is that the secant of negative pi is going to be the same as the secant of positive pi. So we can go to positive pi and we can use its coordinates. Okay, the point on the unit circle that corresponds to this angle is right here, this point. Okay, the coordinates of this point are negative 1, 0. Okay, so if we want the secant here, okay, the secant of negative pi, which is the same as the secant of positive pi, this is just going to be, secant is the same thing as 1 over the x coordinate. Okay, so this is going to be 1 over negative 1. And so the secant of negative pi, which is the same as the secant of positive pi, that's going to be negative 1. That's it. Okay. All right, let's move on to part F. Okay, part F, we are computing the tangent of 7 pi over 2. Okay, we got to locate the angle. We are back to dealing with a positive angle, so the rotation will be counterclockwise. Here's our unit circle. Okay, we need to figure out where 7 pi over 2 lives. Okay, so when you look at this circle, okay, if you scan through it again and focus on the angles, okay, the radian measures, you don't see 7 pi over 2 written down. Okay, remember that tells us that it's just not between 0 and 2 pi. Okay, so what we can do, we've got to figure out what angle on the unit circle is coterminal with it. Okay, so what we can do is, this is a positive angle. Okay, this is meaning that this angle is going to be bigger than 2 pi. So what we can do is take 7 pi over 2 and subtract 1 revolution. Okay, if we take away 2 pi, this will give us an angle that probably will be between 0 and 2 pi, so we can figure out what angle is coterminal with this thing. Okay, so let's figure this out. This is going to be 7 pi over 2. It's already a fraction, but the 2 pi is not. It's over 1. Let's go ahead and change it. We need a common denominator here because we're subtracting fractions. 2 times 1, that's 2. That's going to be the common denominator. So this first fraction is fine. It has the correct denominator. The second one doesn't. So we need to multiply by 2 to make it have the correct denominator. Since we did it to the bottom, we need to do it to the top. So we're going to get 7 pi over 2 minus 2 pi. 2 pi is going to be the same thing as 4 pi over 2. Okay, so we're going to get 3 pi over 2. Okay, and that's on the unit circle. Okay, so this is telling us that 7 pi over 2 and 3 pi over 2 are coterminal. Okay, so if we want the tangent of 7 pi over 2, this is going to be equivalent to finding the tangent of 3 pi over 2. Okay, another way you could have done this, okay, you could have read the angle off of the unit circle. You could have just counted. Okay, so let me show you that really quick just to kind of refresh your memory about how to do this. So here's the x-axis, here is the y-axis. Okay, and then I'm going to draw in the unit circle. And this is just a rough sketch, nothing exact here. All right, so here's a circle. Okay, when you see 7 pi over 2, you need to focus on that denominator. Okay, you need to take the top half of the circle and the bottom half of the circle and break it into 2 equal parts. Okay, so I'm going to kind of highlight this in red so you can see it. I'm going to focus on the top half of the circle. I need to break it into 2 equal parts. Okay, luckily that's done by the quadrants. Okay, so basically by the x-axis and the y-axis, okay, the unit circle on the top is already broken up into 2 equal parts, this part and this part. And the bottom half of the circle is already broken up into 2 parts, this piece and then this piece. Okay, so if we look at the top half of the circle, okay, remember we're starting at 0 radians. Okay, if we rotate the entire half of the circle, that's pi radians. Okay, so if we have pi radians and we're breaking it up into 2 parts, this is going to be pi over 2, or half the circle. This is going to be pi. Okay, so each of these sectors is pi over 2. Okay, so when you start at the initial side and you just start rotating counterclockwise and you're tacking on increments of pi over 2. Okay, so you would rotate and you would get pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, 6 pi over 2, which is 3 pi, and then 7 pi over 2. Okay, if you just draw a little schematic, you can see that 3 pi over 2 and 7 pi over 2 are coterminal. Okay, so now that we've established that, we know what angle we need to look at. Okay, here's 3 pi over 2. The point on the unit circle that corresponds to 3 pi over 2 or 7 pi over 2 is going to be the point 0, negative 1. Okay, so my point here is 0, negative 1. If I want the tangent value, okay, that is going to be the y coordinate over the x coordinate. Okay, so the tangent of 7 pi over 2, which is going to be the same as the tangent of 3 pi over 2, that is going to be the y coordinate, negative 1, divided by the x coordinate, which is 0. Okay, negative 1 divided by 0, that's undefined. Okay, you can't divide by 0. Okay, so can't do this. Okay, this is an undefined value. Sometimes your trig functions at a certain angle are undefined. Okay, this is one of them. Okay, all right, let's keep going. Okay, hopefully you've got the idea down. Okay, all right, in part G, we need to compute the cosecant of 13 pi over 3. Okay, once again, you take a look at the unit circle and you do not see 13 pi over 3. Okay, if you focus in on the angles, okay, this is a positive angle. This is telling us that the angle is bigger than 2 pi. Okay, we need to figure out the angle that it's coterminal with on the unit circle. All right, so I'm going to take 13 pi over 3 and I'm going to subtract out a full revolution. Okay, I'm in radians, so I'm going to subtract out 2 pi. Okay, so I need to be subtracting two fractions over 3. The denominator needs to be 3 here. Okay, the first fraction is fine, leave the numerator alone. The second fraction is over 1. We need the denominator to be 3, so multiply top and bottom by 3. So 2 pi is the same thing as 6 pi over 3. All right, and then now we can just keep the same denominator and subtract across the top. Okay, 7 pi over 3 is a coterminal angle. Okay, 13 pi over 3 and 7 pi over 3 are coterminal. Okay, however, guess who else is not on the unit circle? 7 pi over 3. Okay, so we need to do this again. Okay, so now we can take 7 pi over 3, subtract 2 pi. Okay, so this is going to be 7 pi over 3 minus 6 pi over 3. Okay, and we're going to get that another coterminal angle is pi over 3. Okay, so 13 pi over 3, 7 pi over 3, pi over 3, those guys are coterminal. They have the same initial side and the same terminal side. So to compute the cosecant of 13 pi over 3, that's going to be the same as the cosecant of pi over 3. Okay, if you wanted to draw the circle out, okay, you would do the same thing that we did in part F, but since the denominator here is 3, you would break the top part of the circle into 3 equal pieces, and you would break the bottom part of the circle into 3 equal parts, and then you could count. Okay, every sector would be pi over 3. Okay, all right, so here we go. We just did it algebraically. Okay, let's go to pi over 3. Okay, pi over 3 is going to be right here. Okay, so the point that we need to look at is 1/2 square root of 3 over 2. Okay, so 1/2 square root of 3 over 2. We are computing the cosecant. Okay, so the cosecant, that's 1 over the y coordinate. So if we want the cosecant of 13 pi over 3, we're going to do 1 over the y coordinate, so that's going to be 1 over the square root of 3 over 2. Okay, so we just need to calculate this. The top fraction's 1 over 1, change to multiplication, flip the bottom fraction. Okay, so this is going to be 2 over the square root of 3, rationalize the denominator. The cosecant is going to be 2 square root of 3 over 3. Okay. All right, let's do one more. Okay, this one, okay, we're going to do the tangent of a negative angle. Okay, so this is going to be negative 17 pi over 6. I am running out of room, so I'm probably going to do this one on another page. Okay, so let's see here. This is part H. Okay, this is going to be the tangent of negative 17 pi over 6. Okay, so looking at the unit circle, okay, you again do not see negative 17 pi over 6 on the unit circle. There are no negative angles. Okay, so we've got to figure out which angle this is coterminal with. Okay, so since this is negative, okay, to get an angle on the unit circle, we're going to add revolutions. Okay, and before, when we had a positive angle that was bigger than 2 pi, we subtracted revolutions to get something between 0 and 2 pi. But now that we have something negative, we've got to add increments of 2 pi in radians, or you would add 360 degrees. Okay, if you were in degrees, you would have to add revolutions to get something coterminal that is in between 0 and 2 pi. Okay, so here we go. I'm going to take negative 17 pi over 6. I'm going to add 1 revolution, okay, which is 2 pi. Okay, I'm trying to get this thing to be an angle between 0 and 2 pi. Okay, so the denominator is going to be 6 here, so we need to be adding 2 fractions over 6. The first fraction has the correct denominator, so it's good. The second is over 1, so we need to multiply by 6 to get the correct denominator. Do it to the top 2 because you did it to the bottom. So 2 pi is the same thing as 12 pi over 6. Okay, now we've got the same denominator. We'll keep it and we'll add across the top. Negative 17 pi plus 12 pi is going to be negative 5 pi. Okay, that's still negative. Okay, so it won't necessarily appear on the unit circle. Okay, because there are no negative angles. Okay, so we'll have to add another revolution here. So take negative 5 pi over 6, add 2 pi again. So this is going to be negative 5 pi over 6 plus 12 pi over 6. Okay, add, you'll keep the same bottom, and then negative 5 pi plus 12 pi is going to give us 7 pi over 6. And that is between 0 and 2 pi. Okay, so if I come back to the unit circle, okay, I see 7 pi over 6. It's right here. Okay, here is the ordered pair I need to look at. Okay, 7 pi over 6 and negative 17 pi over 6 are coterminal. Okay, so I'm going to go ahead and write this point down. Okay, this is going to be, the point that I'm interested in is negative square root of 3 over 2, negative 1/2. And I need to compute a tangent value. Okay, so we know that tangent is basically the y coordinate over the x coordinate. Okay, so here to get the tangent of negative 17 pi over 6, we're going to take the y coordinate of negative 1/2. We're going to divide by the x coordinate of negative square root of 3 over 2. Okay, so this is going to be, leave the top fraction alone, change the multiplication, flip the bottom fraction. You have a 2 in the top, it cancels with 1 in the bottom. The negative times the negative will turn positive, so we're going to end up with positive 1 over the square root of 3. We need to rationalize the denominator. Okay, so multiply top and bottom by the square root of 3. Okay, so we're going to get square root of 3 over 3. Okay, that is the answer for the tangent of negative 17 pi over 6. Okay, if you wanted to, okay, again, you could have done a drawing to locate negative 17 pi over 6. Okay, so let me quickly show you that. You can pick whichever way you want to do this. Here's my x-axis. Here's my y-axis. Okay, I'm going to put a circle in here. Okay, because the denominator is 6, I need to break the top part of the circle up into 6 equal pieces, and I need to break up the bottom part of the circle into 6 equal parts. Okay, so give me a second. I'm going to try to draw this. Okay. It's not going to be perfect, but you'll get the idea. Imagine these were all equal sectors. Haha. I wish. All right, so here we go. Okay, so it's going to look something like this. Okay, I see 6 equal parts in the top, 6 equal parts in the bottom. Okay, so we always start with 0 radians. Okay, since this was a negative angle, we would rotate clockwise. Okay, since we took each half of the circle, which is pi radians, and we broke it up into 6 equal parts, each sector is pi over 6. Okay, so if we start rotating, this is negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, negative 7 pi over 6, negative 8 pi over 6, negative 9 pi over 6, negative 10 pi over 6, negative 11 pi over 6, negative 12 pi over 6, negative 13 pi over 6, negative 14 pi over 6, negative 15 pi over 6, negative 16 pi over 6, and then finally negative 17 pi over 6. Okay, so we have found the angle it's coterminal with. Okay, however, it's coterminal with another negative angle. Okay, if we want a positive angle, okay, we would draw one in standard position. Okay, we would rotate counterclockwise until we got right here. Okay, so as a positive angle, this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and then 7 pi over 6. Okay, so that's another way you could come up with the fact that 7 pi over 6 and negative 17 pi over 6 are coterminal. Okay, so I hope this was a really good review of the unit circle itself and how to compute the trigonometric functions of certain angles.